I'm going to go through the answers to the homework that I left you last week. So for question number 1, the first thing we need to do is label the axes. So you'll remember that the vertical axis here is energy, and the horizontal axis was the progress of the reaction. Add the symbols for the reactants and products below the horizontal lines, including the state symbols. So we start with the reactants, so that's NH4, Cl, solid, and the products are NH4 plus AQ, so it's in solution, plus Cl minus, also in solution. Okay, so that's labeled the axes, we've added the symbols. Label the overall energy change. So the overall energy change is the difference between the reactants and the products. So the overall energy change is this change here. Okay. Now it's very important that it points from the reactants to the products. So it won't always be an up arrow, sometimes it might be a down arrow. Okay, so like down here you can see that's a down arrow, but it's always pointing from the reactants to the products. Okay. Okay, so that's the overall energy change. And finally, add a curved line to represent the course of the reaction and label the activation energy. So we need a line that looks like this. And the activation energy is always the energy from the very top of the curve, okay, sorry, from the reactants to the very top of the curve. So that will be going up like that. So that is the activation energy. So go ahead and if you got all that right, give yourself a tick. Otherwise, you need to make a few corrections. Okay, moving on. Question 2. State if the following processes are endothermic or exothermic based on their reaction profiles. In each case, explain your choice based on the relative energies of the reactants and products. So I did the first one for you. So it's one of the second one. Now, we can see that the products are lower in energy than the reactants. So the overall energy change is going down, it's negative, and we know that that's always going to be exothermic. And we can see the energy of the products lower than the energy of the reactants. It's as simple as that. Okay, so you can ask yourself, well, if the energy of the products is lower than the reactants, where is that extra excess energy gone? It's gone into the surroundings. Okay, and that's where you get a temperature increase, because the surroundings increase in energy. And then here we have it's going up. It's an increase in energy. So we know that that will always be endothermic. And the energy of the products is higher than the reactants. Okay, so it's really important that you can always just immediately tell which graph is which. So if it's going down, it's an exothermic reaction. If it's going up, it's an endothermic reaction. Okay, moving on. We have question 3, which I did for you, 3A. Okay, so we saw it was positive, so we knew it would be an endothermic reaction, so it will be going up. All right, so this one here, we can see that this is negative energy change. So it's going to look like this. Okay, we've got the progress of reaction along the bottom. We've got the energy on on the vertical axis. Okay, and it's negative, so it's going to be going down. So my reactants will be up here, and my products will be down here. Okay, I can add in my reactants. My reactants are on the left-hand side, so that will be HClAq plus NH3AQ. And my products on the right-hand side, so that will be NH4ClAq. And we have the reaction profile. Okay, so now we need to add in the overall energy change. And remember, it goes from the reactants to the product. So it needs to go from here. We can sort of come out a little bit if you want. And it needs to go down to the products. Okay, now it must start in line with the reactants, and it must end in line with the products, and it must be pointing from the reactants to the products. Okay, so we have here, this overall energy change is minus 53 kJ per mole. All right. Now, if we wanted to, we could add on up here, pointing from the reactants up to the top of the curve. This here would be our activation energy. Okay. So, in the course of the reaction, we have energy has decreased. We've lost energy. Where has the energy gone? Into the surroundings. Okay, which is why the temperature will increase, because you measure the temperature of the surroundings. And finally, we've got this one. All right, so I draw my axis again. What goes on the x-axis? Progress of reaction. Okay, so it's sort of like time. So we start here with the reactants, end up with the products. On the vertical axis, we have energy, and our reaction is negative. Okay, if it's negative, it means it's exothermic. So the energy of the reactants is going to be higher than the energy of the products. Okay, so our reactants on the left-hand side is H2SO4. And on the right-hand side, the products are 2H plus AQ plus SO42 minus AQ. And the reaction profile, as always, looks like this. And we can add on total energy change. So overall energy change is minus 96. So that goes from the reactants to the products. See, it must start in line with the reactants, it must finish in line with the products, and it must point from the reactants to the products. So that is minus 96. And we could also have the activation energy here. All right, so if you got all those right, well done. If you didn't, make sure you correct them now. Make sure those arrows are pointing in the right direction. Make sure they're lined up with the right things.